As usual, sorry for the technical problems. No matter how much I prepare, it always happens to me. Welcome to the Azure Developers Community channel. And today we have the Azure SDK Community Standup. My name is Hector Norzagaray from the Azure SDK team, and I'm the PM for JavaScript, TypeScript, and for cognitive search. This month, let me cue it up. This month, we will be having the episode 3 of the community stand-up, and we have a really nice topic for today. Let's see what the overview is. So today, we will be talking. Let me see who's controlling. Sandeep, can you move to the next one? First of all, let me introduce the Azure SDK team. We have several PMs in charge of several different services and languages. So we wanted to put the names and the contact information. If you ever are working in an Azure SDK and if you run into a problem or you have any suggestions, this is where you can communicate directly with them via social media. Let's move to the next one. So what's new in April? We're gonna, for the overview today, we're gonna be discussing what's new in April. And the main topic for today will be a passwordless Azure for developers. So in this month, in April, we released several different data and data plane and management plane packages. So we have some Azure SDK for Python for desktop virtualization. We also have Azure Communication Email for Python. We have other health related packages also, and some stable releases for communication for phone numbers for .NET, Java, and Python and JavaScript. So let's move on into introducing the people. So today we're going to be talking about passwordless Azure for developers, and we have 2 guests today, and they're in my team. One of them is Scott Addie. Hi, Scott.
Hey, Hector. How's it going today?
It's going well. The weather is beautiful, so I'm enjoying it. So thank you for joining us today.
Thanks for having me.
And
we're excited.
Yeah, it seems like you have a really interesting topic to discuss. And the other person that is going to be supporting this is Sandeep Sen. How are you, Sandeep?
Hi, I'm good. Happy to be here.
All right. Well, do you want to start with the topic that we have for discussion for today? Scott, what about passwordless? What can you tell us about what Azure is working on the passwordless side of
Sure.
in the services?
Sure. So I'm actually going to start with a question. I know that sounds weird, but my question is going to be, how many of you folks out there have ever changed a password, say in your staging or, God forbid, maybe even your production environment, and you wondered, when I change that password, will I have a job tomorrow? What kind of service interruption will occur due to this password change? It's something that you obviously don't take lightly as a developer, but inevitably that password needs to be rotated at some point. Maybe it's stored as a secret in a key vault, so you've got to deal with that as well. I'm here to tell you today that there's a better way, and that better way is what we call passwordless connections. That is probably the best solution in Azure for this particular problem. So you might wonder, okay, that sounds great, Scott, but what does passwordless connections entail in Azure? It's really 2 pieces here. That's what I'm going to talk through on this slide. Obviously, in any auth scenario, you have your authentication and your authorization. What that looks like in Azure is managed identity for authentication and role-based access control, or RBAC, for authorization. The next question that I'm likely to get at that point is, well, hold on, you lost me at this managed identity thing. What does that really mean? So managed identity is this term that, though it may sound intimidating, it's actually not. Managed identity is a way for Azure to provide a unique security identity for one of your Azure resources. And that security identity, by the way, is fully managed by Azure Active Directory. What do I mean by fully managed? Well, it means really only Azure AD knows the password, knows the credentials to gain access to that account. Under the hood, managed identity is something that we call a service principal. You may have encountered this term elsewhere in Azure. The difference here between managed identity and service principal, all you need to know there is that managed identity doesn't have the administrative overhead of a service principal. Since again, it manages the creation and auto renewal of a service principal on your behalf.
So is it really like Azure Active Directory also gives me my user accounts for Microsoft Office? Is that similar to that?
Yeah, many things Azure are backed by Azure AD at some point. That's your authentication identity provider. You know, if you were to think about what would the elevator pitch be for managed identity, it's really that managed identity eliminates the need for developers to manage sensitive things like secrets, credentials, certificates, keys. You would probably have to store things like keys, passwords in a key vault somewhere. Again, you don't want to have to do that. It's just what I said earlier, administrative overhead. By the way, we mentioned Azure AD earlier when I was addressing Sandeep's question. One of the prerequisites here is that to have a passwordless connection in Azure, the Azure service you're targeting or connecting to must support Azure AD. Good news is most target services do support Azure AD. The last takeaway, probably something you noticed on this slide, there are two flavors, two variants of managed identity, system assigned and user assigned. And the difference there being system assigned managed identities are created and deleted along with the Azure resource to which they're associated. They can only be associated with a single Azure resource, for example, an Azure storage account. User assigned, on the other hand, are created as standalone Azure resources, meaning if you were to delete that Azure resource that you're using it with, the user assigned managed identity would live on. It would not be deleted. System assigned managed identities are deleted when the associated Azure resource is also deleted. One final point there, user assigned managed identities can be associated with more than one Azure resource. As you recall, system assigned, there was a one-to-one mapping. One system assigned managed identity per Azure resource. And then the final piece here is authorization. This is the second tenet of a passwordless connection. RBAC, or again, role-based access control, is what we use in Azure. This is just a mechanism that provides fine-grained access management to your Azure resources. It answers the question, what can this particular managed identity do with those resources? So if we go to the next slide. So just to show you a couple of sample application end-to-end scenarios here. Imagine that you have an app service, Azure App Service resource that has a system assigned managed identity assigned to it. That managed identity is only associated with that app service resource, and you can use it to authenticate to another Azure AD enabled target service. So in the bottom diagram, if we take this as an example, what you see here is, let's imagine there's an Azure App Service instance running, hosting a web app of some sort. And that web app needs to fetch data from a couple of disparate data sources. Let's say Cosmos DB for NoSQL. We're going to use that API in Cosmos. And we also want to connect to Azure Database for MySQL. We'll use the Flexible Server offering. It's the system assigned managed identity that can handle the auth for you to facilitate communication from compute service to target service. And we can take a look at the bigger picture here on the next slide. You see 3 distinct columns on this slide, and what I want you to focus on first is the left side of this slide. It's that source column. These are the major Azure compute services that have managed identity support today. So the idea is you take your compute service, enable managed identity there, and then flow to the right in this slide and determine which client library or driver do I need to use to connect to the desired target service on the far right-hand side of the slide. The idea here, go ahead.
What about my local system? Like this is all on the cloud. What if I want to develop on my local and I want to push that code to cloud, but don't want to mess around and change the code?
Yep. Great question. So just assume that your local development machine is yet another source. It's not depicted on this slide, but let's say you're developing a Java application in IntelliJ. That'll be your source. You'd obviously use the Java client library, or maybe it's a Spring application that you're developing, and you're trying to connect to, I don't know, let's say Azure Database for MySQL. There's another concept we'll talk about later in today's session that would allow that auth to take place locally. Spoiler alert, it's called default Azure credential, and we'll get to that shortly. But again, that client library in the center column will enable token-based authentication to Azure AD, which means we need to provide clients for each of these scenarios that allow that sort of communication to take place. They have knowledge of how to flow that token-based credential type all the way through to the target service. And what you see here on this slide is just a sample end-to-end scenario that I would like to talk through. So in the .NET ecosystem, I'm going to just use this as an example. We have to start somewhere, right? It's very, very common for .NET devs to deploy an ASP.NET Core app to Azure App Service. And let's say that App Service needs to connect to a database. Azure SQL database is the example used here. So what we have here, if we were to look at the App Service in greater detail, is we have a web API running. And the purpose of that is to support CRUD operations on the database that's also hosted in Azure. That particular web API, if you notice here, takes a dependency on SQL client. It's a very, very popular NuGet package that .NET customers would use to connect to SQL Server. But notice there's a transitive dependency here. That SQL client library also takes a dependency on this Azure Identity Client library. It's the Azure.identity NuGet package. Now, in this scenario, for authentication purposes, managed identity has been enabled on that app service resource. And you'll notice there's something that it looks like a connection string because it is a connection string. You'll notice on the right side towards the bottom of this slide, it's actually the bolded portion of that connection string that is the secret sauce here. That is what is enabling authentication to take place. It says authentication equals Active Directory default. What does that mean? You probably have no idea at this point, and that is fine. I will explain. But first, let's talk about the other tenant here, and that's authorization. You might wonder, okay, I'm authenticated with the managed identity. How do I grant that identity access within the SQL database? This is where we're actually going to use database roles to grant that app service very specific types of access in the database. You'll notice there's some a DDL statement, create user, on the bottom of this slide. We're going to create a very specific user named after that Azure App Service resource. And the from external provider keywords there are key to making this work. We're then going to assign 3 roles to that particular user: data reader, data writer, and DDL admin. In short, what those 3 roles are doing is data reader allows you to execute select statements on tables in the database. Data writer allows you to do things like insert, so add records, update records. And then DDL admin would allow you to modify the database schema in some way. For example, create a table like this person's table that you see here. If we then just take a look at the overall end-to-end scenario here. So you have an HTTP GET request to this person endpoint that exists in the web API that eventually triggers this select statement to get sent over to the database. And because we're using managed identity, we don't have to worry about username, password. It's that bolded portion of the connection string that will handle authentication for us and ultimately use managed identity.
So this
So,
select statement is basically fired through the user, which is app service name internally.
correct. So what we've done here is we've created a user in the database that is named after the Azure App Service resource.
And it's just like any other user. That means, like, let's say there is a table schema which is used by, let's say, the SQL admin, right?
Yep.
I can just assign this user a read permission to that schema as well. So it's just another user for
Correct.
customers. Yeah.
Yep.
Okay.
You would, if you're familiar with a SQL Server, just the on-prem product, non-Azure, you would have this same concept available to you where you can create users within the database. That's all we're doing here is we're creating a user in the database and then assigning that user to specific roles so we can control what it's capable of doing in the database. If we go to the next slide, keep in mind as you're looking at this slide, that bolded portion of the connection string. That's what I'm going to talk through on this particular slide. So there's this thing in the Azure Identity Library called the default Azure credential. And though we're talking about .NET right now, know that what I'm talking through here is supported in other languages as well. If you're a C++, Go, Java, Node, Python dev, these concepts apply there as well. Looking at .NET, default Azure credential looks like this under the hood. It's this diagram on the top of the slide. You see all sorts of boxes in this flow chart, and those represent credential types within the Azure Identity Library. Default Azure credential is a pre-configured chain of credential types. And what it's going to do is attempt to use each of these credential types in that particular order. It'll flow from left to right. So another way to think of this is that authentication attempts will continue down that chain until one of those authentication mechanisms has succeeded in obtaining a token from Azure AD. The other cool thing here that's worth noting is default Azure credential is what I would say is environment aware. And what that means is if I use default Azure credential in my application and deploy that to Azure, it has knowledge that in this particular example, I am running my application inside of app service. It knows based on environment variables that are available that yes, this application is running in app service. Therefore, we're running in Azure. And the credential types that appear in orange here, therefore, are not applicable because those credential types apply to the local development scenario only. What I mean by that is you wouldn't be running Visual Studio in Azure. You'd be using that locally when developing the application. So when deployed to Azure, what's going to happen here? It's going to start with the environment credential, and it's going to say, Can I successfully obtain a token using this environment credential? Let's just assume that fails, it doesn't work. It'll then move forward to the next credential type, workload identity credential. Let's say that one fails as well, and then it moves on to managed identity credential. This one, in this particular example, will succeed in obtaining a token. And for that reason, execution will halt at that point. It won't attempt any other credential types that appear in the chain because there's no need to. Does that all hopefully make sense?
I think so. And there are a couple of questions. I know we have a Q&A at a different section, but I want to take them on because they are a bit relevant. So one of the question from Nikos is do we have to use PowerShell or Azure CLI to define and assign roles to Azure Cosmos DB?
Yeah, do we have to use PowerShell or Azure CLI to assign roles to Azure Cosmos DB? You could use those. I believe another option you could explore would be the service connector route. In fact, something like that does exist in public preview right now for Azure SQL Database. Another thing you could explore would be the Azure Developer CLI. That could be another option. And then finally, within the Azure portal itself, you could assign roles.
This is the second question. When it is coming to portal, it's already there, Nikos, so we can use it. And in my demo, I'll show you.
So this question may be asking specifically about Cosmos.
But I think it's similar to every other database. So same patterns can be followed in assigning the service principal.
Yep. I don't know of the current state of support in the portal, but I do know there's work being done there. So if it's not supported today, know that we are actively working on it. Thanks for the questions. I actually wanted to go back to the last slide and show one more detail here because we didn't talk about the bottom portion of this slide where you see this code snippet. This is actually an excerpt from the SQL client library that we're using in this example. And what you'll see in this code sample is that it's using default Azure credential. If you take a look at line 151, it's using the options bag for that credential type. It's hydrating that, setting certain properties, and you'll notice it's being configured in a very specific way. For example, it's saying, hey, we don't ever want to attempt to use the interactive browser credential at the end of that chain. So let's just exclude that, set that property to true. Line 163.
So this means basically in these flow, I'm using it as a flow chart. So I can remove certain credential types from the chain altogether.
Yeah, great question. The answer is yes. So default Azure credential ships with all sorts of knobs. So if you decide, well, this looks good for the most part, but I will never have a use case for authenticating with, let's say, Azure PowerShell. So you could find the property for that credential type in the options bag and exclude that. Alternatively, you might say, default Azure credential doesn't look anything like what I need. Maybe I only want to attempt managed identity when deployed to Azure and then Visual Studio when working locally. In that particular case, something called the chained token credential might be much more appropriate for your scenario. It would result in a lot less code to achieve the same thing. A couple more things I wanted to point out on this code sample. I've included the line numbers intentionally here so I can easily refer to pieces of the code, but line 163 there is how you could get support for user-assigned managed identity in the SQL client library. You would just have to include the appropriate piece of metadata in your connection string. And then finally, line 166 is where the token is actually being acquired from Azure AD. It's that get token async call that you see on the very last line. What that's going to do is sequentially call get token async on each of those credentials in the chain, again, until it has successfully retrieved an access token. And by the way, with credential types like managed identity, there's actually token caching in place. What that's going to do for you is make your app much more resilient. Once that token has been acquired, it'll be cached in memory by default. And then things like lifetime and refreshing of the token are all managed for you. So with that, let's jump into some demos and start to show like real world stuff.
So let's start with the .NET demo.
Cool. So what I've got to show you here is very much what I was talking through in my slides. This is a ASP.NET Core 7.0 Web API. And just to talk through some of the important details here, in my app settings JSON file, line 3, I have a connection string to an Azure SQL database that exists. Again, the very last piece in this connection string is what was bolded in the slides. It's the piece that's going to tell the SQL client library that I am using the default Azure credential in that library. Just to prove to you that that's what's going on here, you'll notice in my CS_proj file, sure enough, on line 11, I have installed the SQL client library. And then what's going to happen is in the API itself, in the program CS file, I fetch that connection string from app settings JSON here on lines 17 and 18. .NET SQL database is the name of the key in app settings JSON. If I go to the beginning of this line, you'll see sure enough, there's that. So that connection string is being retrieved. And below this, I'm just defining endpoints within the API. I've got an HTTP GET endpoint with the person route, and I've got an HTTP POST operation also assigned to the person route. The details that matter there are if I were to send that GET request to the person endpoint, it's going to actually execute this SQL query, select star from persons. And I have in a comment right above that, you know, to make this work, it's the DB data reader role that's required. You need to give that role to your managed identity for this to work. Very similar with the post. It's the data writer role that's required because in this case, if a post comes in, it means we want to add a record. We want to create a person record and add it to that table. So it's running this insert statement. And then I have this region up here that I'm not going to run this, but if you wanted to create something in the database like that persons table, it would involve running this create statement, in which case you would need to be an admin. It's that DDL admin role. So what I've done now is I've shown you the code. You know that this is a real application. I've deployed this out to Azure App Service. And what I'm showing you here is the Swagger test page. So just to show you that this does indeed do something, I'm going to just execute that get endpoint, get person. And hopefully this brings back a 200. It does. And we get back the two records that exist in that person table in JSON format. So how is this all working? What are the important pieces here? That's where I'm going to show you the Azure portal. So here is the web app itself hosted in Azure App Service. And I have, if I go to the configuration blade in that web app, you'll see I've created a connection string. It has that same name, .NET SQL database that you saw for the key in my app settings JSON file. Same exact connection string. The important piece is on the end here. And I've selected that the type of database is SQL Azure. It's an Azure SQL database. So I can exit out of there. The other important detail, though, is using managed identity. We want to assign a managed identity to this web app so that it's able to communicate, it's able to authenticate with that database. That is much simpler than you may be thinking. You would go to the identity blade and make sure that this is toggled on, this status toggle button. Once you toggle that on, it'll, again, under the hood, create that service principal and manage credentials for you. Fully managed identity experience. If you decided to do user assigned managed identity, there's a different tab here for that. But the point is, it's all handled very easily from this page in the Azure portal. Those were the two important pieces in the web app. And so now if I move over to the database, I'm happy to report that as of yesterday, actually, would have been the 10th of April, we now make this even easier for customers out there. We have a passwordless template that we've added to the connection strings blade in Azure SQL Database. So as a .NET customer, you can come out to this ADO.NET tab. The very first connection string template that you will see supports this passwordless connections scenario. We've got a couple of quick starts here to guide you through the process. The one that I'm talking through right now most closely resembles that very first quick start link. But let's say you're using an ORM, like Entity Framework Core. It looks a little different. And for that reason, we've also published a quick start for those customers. So this is where I obtained that connection string from to my database. Now, if we go over to another tab, just to show you the authorization piece, you've seen authentication, authorization now within the database. I've executed this really ugly query here just to show you that these are the three roles that have been assigned to my app service resource. You'll notice the name being used here is exactly the name that's assigned to my app service resource. So .NET SQL followed by some really long number. And if I go back to the first tab, you'll see that it's that same name for that resource. It's just the resource name that I'm using as the username. There's where the access is being granted. And if you were to follow the quick start that I pointed out in the Azure portal, the connection strings blade, you'll also see that eventually you have to come to this networking tab on the logical server itself for the database and just set up some firewall rules so that the resources or people that need to access this database are able to do so. That's all outlined in very great detail in the quick start. So that's how all that's working. I know, so that's .NET. Know that the effort we're putting into this initiative expands far beyond the .NET ecosystem. And so I have Sandeep here to show us an example for all of you Java customers out there.
So before I go on Java, you can look at the link at the bottom scrolling. That's the quick start for .NET for this particular example. You can go there and replicate this. And let me start by going to my Postgres first. Like I'm doing a demo for Postgres, doing the same thing, but on my local. Like a lot of devs, I also develop on my local. I want to do this on my local so that to replicate your developmental cycle. So this is my Postgres resource on Azure. And if you see, it's a normal Postgres. I created it through the normal cycle on the portal. The only thing I added here is I went down there in authentication. By default, it's selected as PostgreSQL authentication only. I added a PostgreSQL and Azure Active Directory authentication and went here and added Azure AD admin. And I added myself because I'm doing on my local. I don't want to add a system assigned identity, I added this, which acts as a user defined identity. So just added it here. And of course, you can do all these things through Azure CLI as well. No need to ever come to the portal, but just showing that can be done in the portal as well. So now we have that, and let's go to databases. So I created the same kind of role in the Postgres database because it's kind of the default and I didn't want to work too much on it. So I just added it on Postgres database. Now let's just go to PG admin for a second, and then we can look at how it looks like in PG admin, because I know most of the people use PG admin as their go-to driver for Postgres. So let me find my PG admin. And give it in. So this is my PG admin. So you see, that's the database, and inside that there is a Postgres, and inside the public schema again there is a person table. This is the table I created, and the owner for this table is my identity, but a PG admin user also has read access. So if I fire this query, select star from person, I have 5 records like Steven, BJ, Tammy, and all that, and you can see that here. Now, since the setup part is almost done, let's jump down to the code part. So in code, I have my VS Code here. Let me find it. Yeah. So we have the VS Code here ready here, and I just want to go through the SQL setup first. Like, these are the 5 records I've inserted it earlier. They are here. I actually granted all privileges to Goofy Shrimp, which was my Postgres admin, because I created everything through CLI. So default admin was my user. Before that, I created the stable as well. And this is we have preloaded a PL/SQL function with which you can actually assign your user here. So this I didn't run, but this essentially creates the user on admin and creates a role. So let's jump onto POM, where what I have actually done. So this is Java 1.8 or Java 8, runs on 11 and 17 as well. And in Java SDK, we actually ask people to use our bombs so that every dependency is managed. All I've done is added a Azure Identity dependency and Azure Identity extension dependency. This extension creates the actual connection. And I've also added Postgres. Standard Postgres, latest version, nothing special here. Then what I've done is this app.java is my main file. Let me just actually. So what I'm doing is I'm running from the properties, reading from properties, and we'll go there, and then creating a JDBC connection. We'll go there again. And then I have a person DAO, and from there is a get all. Let's look at the DAO first. So DAO is just a basic collection interface, standard DAO stuff, nothing important. And in person, what I've done is I'm just running a select query here and converting it to a person model. Person model is also simple Pojo model, nothing special here. So the point is, you don't have to change anything in DAO. You don't have to change anything in your implementation of DAO. Only thing you have to change is read from the properties and do some magic in passwordless in the JDBC connection. So let's look at properties here. This is my connection string, standard connection string. I'm missing the user, the SSL mode, and yeah, those are the only 2 things missing. The second property I added is it is just my user, the user who is going to execute it on behalf of us in local, and this is my admin there. SSL mode for all our Postgres servers, we require SSL, so That's just it. And this is the plugin name. This is equivalent to Azure Active Directory authentication in .NET. This is the plugin name here, which does the authentication for token authentication for us in Java. Just add 3 more lines into the properties, and then we are ready to look at the JDBC connection. So here I have a sample of how to get a connection in JDBC with standard JDBC. You have username, password, and then you do get connection. Similar to that in passwordless, all you need to do is get the URL property, pass it in the URL section, and then pass the full properties bag in the get connection. And this, if you have these things in the property bag and this configured, will try to do a token credential authentication on the database. So enough talking.
Sandeep, I have a question.
Yeah.
How does the JDBC driver authenticate to PostgreSQL in a passwordless way?
So our JDBC driver uses this extension, which we have, and it will try to pass the token, our Azure token, Active Directory token, as a password while building this connection. You'll be more clear on that if I run it. Let me run it. So I'm just using passwordless connection and running the DAO. And let's just try running it. So you'll see. So it's going through the credential part now. Remember, as Scott said, it'll try multiple credentials. So it tried managed identity, didn't find it, went to shared cache, didn't find it, went to IntelliJ, didn't find it, and then finally found it in Azure CLI. My Azure CLI is already logged in. It's sourcing the token from there and dumping it in the Postgres JDBC connection string as a password, and then firing the connection, and then getting these same records like Stephen He and Timmy Hong and Beijing Kon, and we have it here. So
and notice there's something important here in that log output. You notice the words managed identity credential is unavailable. Yeah. Again, that's because managed identity is an Azure only concept. It's not something that exists locally when developing. And that's where something like the default Azure credential is really, really useful. It'll provide you an experience where it'll try to use a local development tool to authenticate so that you don't need managed identity.
Right. And your IntelliJ can also actually cache the token. For me, since I'm not using IntelliJ and not using VS Code credential right now, I'm using Azure CLI credential. And how do I know that? Because first, Azure CLI credential returns a token. This I'm logging, and that's what is using. But if I use Azure account show, it says, hey, I'm in the resource group and all. This is my user and all. So that basically ends the demo. And
yeah, there's one more thing that I'd like to do here. To Hector's question, if we could share my screen, I've actually found a nice diagram that shows what's going on with that JDBC auth plugin that Sandeep was using. You can see that it's a two-step process, really. The auth plugin itself takes a dependency on the identity client library for Java, sort of like what we saw with the SQL client taking a dependency on the Azure Identity Library for .NET. It's that Azure Identity Client Library that then acquires a token, managed identity token, from the appropriate endpoint in Azure Active Directory. That access token is sent back up to the JDBC driver, which will use that token and smuggle it into the password field to accomplish authentication. So hopefully that helps make it a little clearer. I'd also note that what Sandeep showed, we have a very similar story for our MySQL Flexible Server. So if you aren't using Postgres in your Java app, you're using MySQL instead, we also have an auth plugin to support that.
Yep. And basically, what we are trying to show here is it's not only Azure products which have passwordless connections. We are slowly rolling it out to other open source products. Prime example, Postgres here, not owned by Microsoft, but we have a passwordless experience here as well. That too from your local, and definitely you can replicate when you uh, push the same code to, you make no changes to this code and you push it up to your hosted application somewhere in Azure, which will then, instead of picking Azure CLI credential, will pick up managed identity credential and use the token as a password.
Well, thank you so much for the demos and for all this information. I like the fact that you showed us both in .NET and in Java. How does that work? For more information, you can always go to the documentation to see how the other languages will manage it, right? How to do it in Node. If you're a JavaScript developer, things are different, but not that different,
right,
coming from .NET and Java. So that's one of the ideas we have in the SDKs, right? Like trying to make the product work for all the languages as similar as possible. There's a lot of people that use one language or the other, so.
Yeah, so we do have support for 4 languages right now: .NET, Java, JavaScript, and Python. You can go to aka.ms delete passwords, running as a ticker at the bottom of your screens. That's our hub page, and you can see the exact example where Scott and I ran, and many more examples and many more products supporting passwordless. And we'll slowly roll out to more products.
If we could show the next slide, I want to talk a little bit more about that link that you were scrolling on the bottom. What you see here is a screenshot from that delete passwords page. We call this our passwordless hub. 2 different types of docs that you're going to find out here, others as well, but 2 major types. If you're a customer who's new to a particular service and you want to use passwordless connections, you're going to be interested in our quick start documents. We have language specific entries in the table of contents here. You'll see the 4 languages we mentioned on the left side: .NET, Java, JavaScript, Python. Take a look at those for a nice getting started experience for passwordless. If, on the other hand, you are a customer who is using something else to authenticate, like username, password, for example, we've compiled a suite of migration guides for those types of customers. And you can find those under that delete passwords and migrate table of contents node. So please do take a look at this, send us your feedback, and know that content will continually get added to this hub.
Yeah, always remember to follow the Azure SDK blog also for publications like this. So in the Q&A, there was one question from Eolini, or I'm sorry,
Eloni, I think.
Yeah. What does management ID do? Can anybody answer that question?
Yeah, I think so. That management ID, I assume, refers to the managed identity. This is, think of it as an account that is fully managed by Azure Active Directory, which is our identity provider. Managed identity allows you to authenticate a target or a source service to a target service without the need to manage credentials for that account that's being used for the authentication. Azure Active Directory takes care of that ugly stuff for you.
And as Scott said, managed identity is linked to the resource you create. Let's say you created a Postgres server. That managed identity would have the same life cycle as the Postgres server. When you delete that Postgres server, that managed identity is also gone forever. So in this way, if you delete a resource, you can be rest assured that nothing is lingering around.
Yep.
All right. Well, I think we are pretty much done for now. But let's put the slide with the contact information or how to follow us. How to use our SDKs. You can always go to Azure SDK, aka.ms, Azure SDK releases. You can go to the GitHub to give us feedback or to contribute. Follow us on Azure SDK. and subscribe to the blog. Now, I'm going to give a little teaser. Next month, in our next show, we're going to be talking all about AI and what we're doing with AI on the Azure SDK team. So please make sure to follow us and join us for the next episode of this show. All right. Thank you so much, Sandeep. Thank you so much, Scott. This was great.
Thank you.
Thanks for having me. Appreciate it.
Thank
Thanks,
you.
everyone, and we'll see you next time.
Yep. Bye.